Hey YouTube, welcome to a WTF video. Mining the moon. Yep, we're coming to the stage where we're going to start mining the moon for raw earth materials, metals. One in particular that is really an important, they think it exists there, they probably know obviously, is an isotope of helium-3. It's a fuel source for nuclear fusion. So clean energy and all that kind of stuff, obviously to help the rockets and all that kind of stuff and energy around Earth. I heard it's also can be used for quantum computing. Don't know how, but anyway, they know. They're going to start building moon bases, which they probably already have, already are, I guess. We only hear a little bit. I mean, they know exactly what's going on. But the fact is, they are going to create a moon bases, and they're going to mine the moon. Now, I mean, what impact does that have to the moon? And will that impact affect Earth? I've got a video coming up that goes for 7 minutes. Stay tuned and watch it. I'll try to be quick with this one. But, stay on and watch that video. It only goes for 7 minutes, but, it is really interesting to see. But, to me, what the effects would be about mining the moon, we see what the mines look like on Earth, just tracks going round and round and going down and deep holes. And, we're digging, we're mining the shit out of this Earth. And obviously we're probably maybe starting to run out of materials, who knows? But think about it. If we dig and dig more on the moon, how does that affect the moon's orbit around the Earth? I don't know. But I would think it would have some sort of impact decades down the track. Now, I think they are planning or hoping to do the first mining within about 10 years. Obviously, we need to get the technology right and going there, mining, loading the rocket up and bringing it back. Guess once we get that technology right, the mining starts. Mining starts. So, but what worries me also is that look at us now on planet Earth, how we fight over resources. There's been movies where people are fighting on the moon. Will we do that? We probably will eventually. I know we've got this kind of agreement where no one owns the moon, no one owns space, obviously, but the powers to be, eventually there's going to be some, hey, you can't mine there, you can't do this, you can't do that. You can just picture the snowball effect of what could happen by mining the moon and having bases on the moon and being human nature, unfortunately, the fights to own those minerals. Anyway, but the future is here and the future is coming. So anyway, I'm not going to talk too much. Check out the video. Please let me know what you think, and leave some comments, because I'd like to understand what your point of view is on these subjects that I'm showing you. So anyway, enjoy the video. And this picture, by the way, was done by my daughter. I absolutely love it. So there you go. I thought it'd be a nice backdrop for this one. Cheers.
The moon, a silent guardian in our night sky, has captivated humanity for millennia. Now, a new era of lunar exploration is on the horizon, driven by the prospect of mining its hidden riches. Imagine a future where lunar industries fuel our energy needs, supply vital resources, and propel us further into the cosmos. This is the tantalizing possibility presented by lunar mining. The moon harbors vast reserves of valuable elements and minerals, some of which are scarce on Earth. The prospect of lunar mining has already sparked a new space race. Private companies and government agencies are investing heavily in technologies to extract and utilize lunar resources. The goal is to establish a sustainable presence on the moon, one that goes beyond scientific outposts. This new era of lunar exploration is not without its critics. Some argue that exploiting the moon for its resources is ethically questionable and environmentally risky. As we stand on the cusp of this new frontier, it's crucial to carefully weigh the potential benefits of lunar mining against its potential drawbacks. The choices we make today will determine the future of the moon and its role in humanity's cosmic journey. The moon is becoming a potential treasure trove of resources that could shape the future of humanity. The moon is more than just a celestial neighbor. It's a time capsule preserving the history of our solar system. Its surface, scarred by billions of years of impacts, holds invaluable clues about the early solar system and the formation of planets. By studying lunar rocks and craters, we can piece together the events that shaped our cosmic neighborhood, including the very origins of Earth. Unlike Earth, where geological processes constantly reshape the surface, the moon's surface remains largely unchanged over eons. Lunar samples brought back by the Apollo missions have already revolutionized our understanding of planetary formation. Deep within its icy polar craters, scientists believe there may be deposits of water ice dating back billions of years. This ancient ice could contain trapped gases and organic molecules, providing invaluable insights into the early solar system's composition. By venturing deeper beneath the surface, we can uncover new layers of lunar history and gain a deeper understanding of our place in the cosmos. The scientific discoveries made possible by lunar mining could have profound implications for our understanding of the universe. Beyond its scientific value, the moon holds immense economic potential. It harbors vast reserves of helium-3, a rare isotope on Earth that could revolutionize energy production. Helium-3 is a potential fuel for nuclear fusion, a process that releases vast amounts of energy without producing long-lived radioactive waste. This makes it an incredibly attractive alternative to fossil fuels and current nuclear fission technology. While fusion power remains a technological challenge, the potential rewards are enormous. A single ton of helium-3 could generate enough energy to power a city for a year, and the moon is estimated to contain millions of tons of this valuable isotope. Harnessing lunar helium-3 could provide a clean and sustainable energy source for future generations. In addition to helium-3, the moon is rich in rare earth elements, vital components in modern electronics, renewable energy technologies, and advanced manufacturing. Mining these resources from the moon could offer a more sustainable alternative, reducing our reliance on Earth's dwindling reserves. The moon could also become a source of valuable metals, water ice for rocket fuel and life support, and even construction materials for future space habitats. Section 4. The shadow of industry environmental concerns on the moon. As we venture towards a future of lunar mining, it is crucial to acknowledge the potential environmental consequences. Earth's own history with resource extraction is rife with examples of environmental devastation, serving as a stark reminder of the need for responsible and sustainable practices. Lunar mining, if not carefully managed, could disrupt the moon's pristine environment. The extraction process could generate dust clouds that interfere with scientific instruments and potentially pose risk to human health. The disposal of mining waste could contaminate the lunar surface, compromising its scientific value. Addressing these concerns requires international cooperation and the establishment of strict environmental regulations for lunar activities. We must prioritize the development of sustainable mining technologies that minimize environmental impact and ensure the preservation of the moon's scientific and ecological integrity. Section 5. A Space Race 2.0 Politics and the Future of Lunar Mining. The prospect of lunar mining has ignited a new space race, one where nations and private companies are vying for a stake in the moon's resources. This raises complex political and legal questions about resource rights, international cooperation, and the potential for conflict. The 1967 Outer Space Treaty prohibits national appropriation of celestial bodies, but remains ambiguous about resource extraction. The emergence of private companies in the space industry adds another layer of complexity. Establishing clear guidelines and agreements on resource rights, environmental protection, and profit sharing is crucial to prevent conflict and ensure that the benefits of lunar mining are shared equitably among all of humanity. Section 6. Stepping Stones to Mars, Lunar Bases and Human Expansion. Lunar mining could be the key to unlocking humanity's expansion beyond Earth. The resources mined on the Moon could support the construction and operation of permanent lunar bases, serving as stepping stones for further exploration of our solar system. Imagine lunar bases as hubs of scientific research, resource processing, and even tourism. These bases could be self-sustaining, utilizing lunar resources for energy, construction materials, and even food production. The Moon's proximity to Earth makes it an ideal testing ground for technologies and strategies for living and working on other celestial bodies. Lessons learned on the Moon can be applied to future missions to Mars and beyond, paving the way for a permanent human presence in space. Section 7. A cosmic dilemma weighing the benefits and risks of lunar mining. The prospect of lunar mining presents humanity with a profound dilemma. On one hand, it offers tantalizing solutions to our energy needs, resource scarcity, and desire to explore the cosmos. On the other hand, it raises ethical concerns about environmental stewardship, resource rights, and the potential for conflict. By engaging in open and honest dialogue, prioritizing international cooperation and sustainable practices, we can strive to create a future where humanity's reach for the stars is tempered by wisdom. The choices we make today will determine the legacy we leave on the Moon and our future among the stars.